In this lesson, we will continue talking about the properties of exponents, but this time you will also experience negative exponents. So let's take a look at some notes and examples that better explain this concept. As shown in the box in these notes, the goal of simplifying exponential expressions with negative exponents is to simply get rid of all negative exponents. So in your final answer, there should be no negative exponents, all positive. So let's take a look at some examples of what this might look like. So right here we have a to the negative n. When there is a negative exponent, you want to take its reciprocal, which means to flip the fraction over, and when you do, the exponent will become positive. So notice a to the negative n gives us the answer of 1 over a to the n. Let's look at that with a different variable. In the next example, it says x to the negative 2. So if we take the reciprocal, it simply flips the fraction over, and when you do this, the 2 becomes positive. We will do the same process when the exponent of negative 2 has a base of 5. So we will make it a fraction and take its reciprocal. The only difference is, as seen in previous lessons, if the base is a number, we need to calculate that expression. So 5 squared would give us 25. So 5 to the negative second power equals 1 over 25. If we look below, this time we still have a negative exponent, but our expression starts out as a fraction. But again, we simply take the reciprocal, which means we flip these over. So if you want to see what it would look like with the 1, it would be a to the n. Notice the n is now positive over 1, and anything with a 1 in the denominator is simply the numerator. In the example to the right of that, 1 over x to the negative second power, again, if you flip that over, its exponent becomes positive, and our answer would simply be x squared, depending on whatever x is. Looking at an example where the base is a number, 1 over 3 to the negative first power, if we take that reciprocal, it would be 3 to the first over 1, and 3 to the first is just 3, and that's how we will write our answer. Let's take a look at some additional examples to better explain these negative exponents. This says to study the patterns for the variables below, then fill in the answers for the a's and the b's. So if you start by looking at the x's, notice x to the negative 3, if we take its reciprocal, is 1 over x cubed. X to the negative 2 is 1 over x squared. X to the negative 1 is 1 over x to the first, or just 1 over x. X to the 0, as we've learned in a previous lesson, is simply 1, because anything to the 0 power equals 1. X to the first power is x. X to the second power is still x to the second power, and x cubed is still x cubed. So when the exponents are positive, nothing changes. But when the exponents are negative, we must make those exponents positive by taking the reciprocals of the expression. And you will notice as you study the y's, you will see the same pattern. So let's go ahead and fill in the answers for the a's using the same pattern that we found in the x's and the y's. So a to the negative third, if we took its reciprocal, would simply be 1 over a cubed, because once we take its reciprocal, its exponent becomes positive. A to the negative 2, if we take its reciprocal, would now be 1 over a squared. A to the negative 1 would be 1 over a to the first, or just a. Then anything to the 0 power equals 1. And the remaining 3, because their exponents are all positive, do not change. So a to the first we can write as a. The other two we will keep exactly the same. Doing the same for the b's, we would have 1 over b cubed for b to the negative third power, 1 over b squared for b to the negative second power, 1 over b to the first, or 1 over b, for b to the negative first power, back to b to the 0 power, which is 1. Then the last three, because their exponents are all positive, nothing will change about those expressions. Let's take a look at some additional examples. Here, we have numbers instead of letters for our bases, but the process is the same. The only difference is once we take the reciprocal of the expressions with the negative exponent, we then need to simplify our answer. So if you look at the 2's, 2 to the negative third, if you take its reciprocal, is 1 over 2 cubed. But 2 cubed equals 8. 2 to the negative second power is 1 over 2 squared. 2 squared equals 4. And 2 to the negative first power, or 1 over 2, doesn't change. It remains 1/2. And from there, 2 to the 0 power equals 1. And then the other three, which have positive exponents, you simply calculate as you've always done with exponents. If you study the 3's, you will see the same pattern occurs, as well as the 4's. Let's take a look at the 5's and the 6's. For the 5's, 5 to the negative third is 1 over 5 cubed, and 5 cubed, or 5 times 5 times 5, is 125. 5 to the negative second power is 1 over 5 squared, and then 5 squared is 1 over 25. 5 to the negative first is 1 over 5 to the first, and 5 to the first is simply 1/5. From there, 5 to the 0 power is 1, 5 to the first power is 5, 5 squared is 25, and 5 cubed is 125. So notice 5 to the negative third and 5 to the third power, their answers are simply reciprocals of each other. When the base is 6, 6 to the negative third power, or 1 over 6 cubed, 6 times 6 times 6 would be 216. 6 to the negative 2 is 1 over 6 squared, which is 1 over 36. 6 to the negative 1 is 1 over 6 to the positive 1, which is simply 6. From there, 6 to the 0 power is 1. 6 to the 1 is just 1. 6 squared is 36, or 6 times 6. And 6 cubed is 216. 6 times 6 times 6. Now let's take a look at some additional examples incorporating these negative exponents. Here it says, study these 3 problems below, then answer the questions that follow. Number 1 says, in the first example, which would be this one here, why do you think the y cubed moved to the numerator, but the x squared did not move? If you look at this expression, remember, if the base has a positive exponent, it remains the same. If it has a negative exponent, you take its reciprocal. In this case, reciprocal simply means flip it to the opposite location. So for the bases with the negative exponent, taking its reciprocal, if it's in the denominator, means moving it to the numerator. When you do that, there would be no more denominator in this problem, which is why your answer is simply x squared y cubed. Notice there are no more negative exponents, which is one of the goals of simplifying these problems. So in this first question, the way that you might answer this is that y cubed had a negative exponent, and this is the reason why it was moved. The second question says, in the second example, which would be here, why do you think both the a to the fourth and the b squared moved to the denominator? Again, this time both bases have negative exponents, so therefore we need to take the reciprocal of both bases. So each of them will flip to the denominator to make their exponents positive. In doing so, there will be nothing left in the numerator, so we will fill this in with a 1. So again, to answer this question, why do we think both of them moved to the denominator? We can say both had negative exponents. The third question says, in the third example, why do you think only the m moved to the denominator? Well, if you look, there are 3 bases. The 2 has its own exponent of 1, the m has an exponent of -1, and the n has an exponent of 2. So the only base with a negative exponent is the m, which means it should be the only thing that moves to the denominator. The 2n squared will stay exactly where it is. So again, our answer would be m is the only base with a negative exponent. So let's take a look at some final examples. In number 4, it says x to the -4th power, y to the 6th. To simplify this, we simply want to make the exponents that are negative positive. So if you look at number 4, the x has a negative exponent, but the y has a positive exponent. So which one do we need to take the reciprocal of? Of course, the x. So to take its reciprocal, we will simply move it to the denominator. Because the exponent of the y is positive, it should not move at all. So it will remain in the numerator, but the x will move to the denominator, making its exponent positive. In problem 5, which base, the c or the d, needs to be moved to the denominator? Hopefully you're thinking both, and you're correct, because both of them have a negative exponent. So if we move them both to the denominator, their exponents will become positive. We cannot leave the numerator with nothing there, so what would we fill in the numerator? Hopefully you're thinking a 1. Now the only part of that answer that we don't need is the little exponent of 1 with the c. So your final answer can be written as 1 over c d to the 9th. In example 6, which of the 3 bases do we need to take the reciprocal of? Only the b, because it's the only one with a negative exponent. So the 4 and the a will remain in the numerator, but the b we will move to the denominator, making its exponent positive. In the last problem, which of the 3 bases, the 4, the x, or the y, do we need to take the reciprocal of? Only the x. So the 4 and the y to the 4th must stay exactly where they are because their exponents are already positive, but we will move the x to the -2 to the denominator, making its exponent positive. So our final simplified answer would be 4 y to the 4th x squared. And that completes the lesson on negative exponents.